Archimedes was known to be the sharpest guy in Syracuse. Syracuse is of course in Sicily, which is now part of Italy, but in Archimedes' time around 250 BC, Sicily was part of Greece. Anyway, being the sharpest guy in town meant that whenever townspeople had difficult problems they couldn't solve on their own, they always went to Archimedes, even the king. Syracuse's king Hiero II had a problem. To show his gratitude to his countrymen for making him king, he had wanted to place an exquisite golden crown in a local temple. So he had measured out a precise amount of gold and contracted a goldsmith to fashion the crown with it. The goldsmith had done as ordered and delivered a beautiful gold crown which weighed the same as the gold he was given by the king. So the king was satisfied and paid the goldsmith handsomely. A few days before the ceremony where the king would place a crown in the temple, the king heard some rumors that the goldsmith had tricked him. The goldsmith had, the rumor said, only used part of the gold to make the crown and mixed in some silver to make up the weight, keeping the remaining gold for himself. The king was furious, but being a fair-minded guy, couldn't bring himself to punish the goldsmith unless he could prove that the goldsmith had indeed tricked him. But how to prove it? The crown weighed the same as the gold the king had given the goldsmith. The king went to Archimedes and tasked him with figuring it out. Archimedes knew that gold was denser than silver. So if the crown had silver mixed in with the gold and it weighed the same as the pure gold, it had to have more volume. But how to determine the crown's volume? He couldn't exactly melt it down, make a cube of it and measure it. How could he measure the volume of an irregularly shaped object? That was the question. The ancient Greeks were advanced in many ways, but indoor plumbing wasn't one of them. Bathing took place in public baths, where there were communal pools for social bathing as well as individual tubs. The king's assignment weighing on his mind, Archimedes walked over to the baths, hung up his toga, and immersed himself in an individual tub. The tub had been filled all the way up to the rim, so as Archimedes lowered himself in, water splashed out. It's fun to think of scientific breakthroughs as moments, lucky breaks. Alexander Fleming left some dirty dishes unattended for a couple of weeks, came back, saw the mold, and invented penicillin. Perry Spencer walked in front of a vacuum tube used to generate microwaves, noticed that the chocolate bar in his pocket had melted, and invented the microwave oven. George de Mestral was hiking and found burrs clinging to his pants and his dog's fur, and invented Velcro. And so on. We like to think of these breakthroughs as lucky breaks because they support the narrative that instead of Fleming, it could have been me that discovered penicillin if I were less fastidious about dirty dishes. Or it could have been me that invented Velcro if only I were more of an outdoorsman. But it doesn't work that way. Generally, these moments require years of preparation before and years of hard work after. If it were me and not Fleming, I would have just cleaned the dishes. Fleming's years of work in microbiology were what enabled him to recognize the significance of what he saw and what allowed him to do the work needed to convert the discovery into a viable medicine. So, back to Archimedes. Being a great mathematician, physicist, and engineer, Archimedes saw the water splashing out of the tub as he lowered himself into it and figured out exactly how he would solve the king's problem. He was so excited about his discovery that he ran out of the tub and all the way home, forgetting to grab his toga, and thus treated his fellow Syracusans to the sight of a middle-aged scientist running buck naked and soaking wet. Along the way, he kept yelling, "I found it, I found it!" Except, of course, he yelled it in Greek. Eureka! Eureka! In the bath, Archimedes had discovered that when an object, or a human body for that matter, is immersed in fluid, it displaces a volume of fluid equal to its own volume, regardless of the object's shape. He now had a non-destructive way to determine the crown's volume. He filled the bowl with water, all the way to the rim. Then he lowered the crown into the bowl. Some water splashed out. Archimedes measured the water remaining in the bowl, and the difference between that measurement and the total capacity of the bowl gave him the volume of the water that the crown had displaced, which was equal to the crown's volume. He then took a lump of gold weighing the same as the crown. If the crown had been fashioned with pure gold, the lump of gold that weighed the same as the crown would displace the same amount of water, since it would have had to have the same volume. It didn't. The crown displaced more water than the lump of gold of equal weight. Therefore, the crown had more volume than the lump. The only way that could be the case was if the crown was not made up of pure gold, but of gold plus materials of less density, such as silver. The goldsmith had, indeed, cheated the king. Thus was born Archimedes' principle. The upward buoyant force that is exerted on a body immersed in fluid is equal to the weight of the fluid that the body displaces. Archimedes' principle is a law of physics fundamental to fluid mechanics. Thus was also born the way that we would, from that moment on, refer to moments of sudden triumphant discovery, inspiration, or insight. Eureka moments. Makes you glad the ancient Greeks had no showers. I'm Jack Azut. Thank you for watching.